Last time we studied separable differential equations, and today we will study homogeneous, and then we will study exact differential equations, and next week we will study linear and Bernoulli differential equations, and we will finish first order differential equations. Then we will start second order differential equations, how to solve. We will learn all the techniques how to solve first order and second order differential equations. And today let's start with first order homogeneous differential equations. What are these? So these are first order differential equations. Let's say we have dy over dx is equal to f of xy. So if the function f of xy can be written as a function of y over x or x over y, then this equation is called a homogeneous differential equation. Okay, let me give example, then it will be clear. So let's say that we have dy over dx is given as y squared plus 2xy over x squared. So this is a first order differential equation. We have only the first derivative dy y prime. So this is equal to f of xy, right? Can we write this function as a function of y over x? So let's see. If we divide everywhere with x squared, we will get 2xy over x squared, and we can write this function as, and here we cancel so one of the x's, so we have 2 times y over x. So as you see, we write dy over dx is equal to f of xy as y over x squared to y over x. So this is a homogeneous. So this is an example of homogeneous differential equation. Great. We will learn in a second how to solve this type of differential equations, but let me give more examples. So for example, okay, let's say that we have dy over dx is equal to y cubed plus 2xy over x squared. So if we if we apply the same idea, like we divide everywhere with x squared, so we have y cubed over x squared plus 2xy over x squared. So here we have y times y over x plus 2y over x. But this is, because of this y here, so we don't want separate y or x's in the equation. So we just want to see only y over x or x over y. So x over y is also okay. But since this y term, it is not a, so it's not a, maybe I will write, not a homogeneous differential equation. Okay, let me give another example. For example, let's say dy over dx is equal to ln x minus ln y plus x over y. So if you look at this, can we write it f of xy as a function of x over y? So y over x or x over y. Here we can use the properties of ln function. So we know that this ln x minus ln y, we can write it like this, plus x over y. So dy over dx is equal to, so this is our, we write the function f as a function of f of xy. So maybe I will write this. So recall we have such a formula, right? ln xy is equal to ln x plus ln y ln x over y is equal to ln x minus ln y. So recall this formula. Great, so now we are ready to solve homogeneous differential equations. How to solve homogeneous differential equations? So let me write solution method. So we will use change of variables. So by a change of variables, we can reduce homogeneous differential equations to something we know, something very easy, to separable differential equations. Separable equations. So which change of variables we will use? We will let y over x to be u. So we will use this change of variables. Then what is y? Y is u times x. So we are given dy over dx. Okay, let me write it from the beginning. Okay, sorry about that. So let's say that we are given dy over dx f of xy, and we write this function. Let's say we write it as a function of y over x. The x over y case is similar. Then we will change y over x to be u, so we will substitute. Where we see y over x, we will substitute u. But what we will put instead of dy over dx, so when we take the derivative, so this is a product rule, right? So if you remember derivative of the product, so it is du over dx times x plus u times dx over dx. The derivative of x with respect to x is, so this is 1. So this is 1. And we have, so we have dy over dx is equal to u plus x times du over dx. Now we have a separable differential equations, or we can write y prime is equal to, or sometimes we write y prime is equal to u plus x u prime. So this is a separable differential equation. So this will be a separable differential equation. Okay, let me solve some examples. Then it will be clear, yeah. Okay, let me do example. So first one, okay, solve the following homogeneous differential equation. Okay, it is given as y prime is equal to y prime is equal to 3x plus y over x, and the condition, we have the initial value problem, so this is an initial value problem, but it is homogeneous one, and it is given that y1 is equal to, with this condition, y1 is equal to 0. Okay, is this homogeneous? Let's check it. So it says homogeneous, so it should be right. Solve the homogeneous differential equation. So this is actually a homogeneous differential equation, y over x. So what we are going to do is we let y over x to be u. So y is equal to x times u. Take the derivative. So what is y prime is equal to derivative of xu. So this is a product rule. Derivative of x, it is equal to 1 times u plus x times u prime. Then we will substitute this into the equation. Oops. We will substitute y prime here, y over x here. So we will have, okay, let me do it here. Y prime is equal to 3 y over x. So we find y prime is equal to u plus xu prime, 3 plus u. So now we have a very easy differential equation, right? So we have xu prime is equal to 3 plus u minus u. So these will cancel. U prime is equal to 3 over x. Okay, I have to continue to the next page. Okay, let me write it again. 3 over x. What was u prime? It was du over x is equal to 3 over x. So it is separable. We collect u terms to the other one side, x terms to the other side. So this is 3 over x dx. So recall how we solve separable differential equations. And then we integrate. We just integrate. What is the integral of du? It is u. What is the integral of 3 over x? So it is ln absolute value of x plus c. So recall, we know that the integral 1 over x dx is equal to ln x plus c, the absolute value, because the ln function is not defined for negative values. Or in general, whenever we have ax plus b dx, so this is ln ax plus b over a plus c. So we don't forget c. Sorry, I will. Plus c. So don't forget plus c. Great. So what we find is u, but don't forget u was equal to y over x. We have to put y over x. So ln x plus. So did we do anything wrong? Oh my god. No, we are right. I think we are right. Right? Yes, I think, I see what I did wrong. Okay, no problem. Okay, we are correct. So sorry, I was confused because the tree was like I write the example wrong. So it should be 3x plus 3y, but it's okay. So this is correct. This is correct. In my notes, I forget. I write the other way around. So in my lecture notes it was 3y, but this is completely correct. So great. Okay, this is the solution. You can leave it like this. So but we have one more thing. So one condition we want the condition y1 to be 0. So what does this mean? If we put x is equal to 1, y should be 0. Then what is c? C is 0 in this case. Because if we put y 0, 0 over 1 is 3 ln 1 plus c. But ln 1 is 0, so c is equal to 0. So solution of the initial value problem is y over x plus 3, is equal to 3 ln x. Great, let's continue with the other example. Okay, let me solve another example. Another example, okay, solve y prime is equal to x cubed plus 2y cubed xy square, and we have this condition y1 is equal to 1. I hope I write this correct, so let me check. Great, okay. So let's check, is it homogeneous or not? Or is it separable or not? Because if it is separable, then it is very easy to solve, so we don't need to solve by using homogeneous. But it's a homogeneous one. So we will divide x cubed by xy square plus 2y cubed xy square. Then what we have x square over y square plus 2y over x, right? And we can write this x square over y square as y over x squared plus 2y over x. Great. Then what we are going to do is we will let y over x to be u. Okay, I will continue in the other side. So we let y over x to be u. Then y is equal to x times u. If we take the derivative xu, the derivative of x times u is the product rule. The derivative of x is 1. The derivative times u plus x times the derivative of u prime. So product rule. Recall product rule from calculus. Then we will y prime or dy over dx by, so how was our y prime was equal to 1 over y over x square plus 2 y over x. Okay. So, okay, let me write it here. Y prime was equal to y over x square plus 2y over x. And we will put y prime, this term. So y prime u plus x u prime is equal to 1 over u square plus 2u. Now it should be separable, so because this method will reduce homogeneous differential equations. to be separable, and I put this u to the other side, so I will get u. So this is actually 1 plus u2 cube over u square. So we have x u prime is equal to 1 u cube over u square. Now it is separable. We can so we can collect u terms to one side, x terms to the other side. So we will multiply with u square and we will divide with 1 over u cube, and we take x's to the other side, dx over x. Great. Now we will integrate. But to integrate this part, we need to do one more substitution. So to integrate, we need to do one more substitution. So substitute, let's say s is equal to 1 plus u cube. So what is ds? It is 3u squared du. So we have u squared du over there, right? So we can put ds over 3 when we see u squared du. So here we will get, so this part will become ds over 3 s. Oh, okay, this will be ln x, but let's take it all of them together. So we have ln s plus, sorry, ln s is equal to ln x plus c. Now we will put s back. So s was 1 plus u cube, and at last we will put at the last step, we should put u is equal to y over x. Don't forget that. So s was 1 plus u cube, but don't forget that u was y over x. So it is ln 1 plus u cube ln, by the way, absolute value of x plus c, 1 over 3 ln 1 plus y over x cube ln x plus c. But we also have one condition. So our condition was y1 is equal to 1. So we will put 1. Okay, let me copy this part. Okay, we will now, wherever we see x, we will put 1, and it says that the condition says that when x is equal to 1, y is also 1. So what we have, 1 over 3 ln 1 plus 1 cube ln 1 plus c. So this is 0, and c is equal to 1 over 3 ln 2, or you can write it like this. So you can take 1 over 3 to the inside. So it is ln 2 to the power 1 over 3. So you can also have this. Then what is our solution? So solution of the initial value problem is, we have 1 over 3 ln 1 plus y over x cube is equal to ln x plus absolute value ln to the power 1 over 2. So this is our solution. If you want, you can write it in a nice form, but this is okay for me, but you may write it like this, so you may simplify. Like this. But is it okay to live like this also? Y over x to the power 3, 1 over 2, 3. So this is a plus, we can write it like this in a multiplication form. And then we can cancel ln functions. So this is also okay. Okay, I will continue to solve examples in the next video, because in part 2, because I don't want the video to be too long. Okay.